All right, so now we're going to finish our discussion of unit conversions by talking about other conversions that need conversion factors, but specifically outside of just metric prefixes. So going from like inches to centimeters or pounds to kilograms, these types of conversion factors. And importantly, what we're going to need is this constants page is what we're going to be using over and over and again, and what I want you guys to get familiar using, because this is what will be on the exam. So first of all, just note that this bottom one here, this is the table that we've been using up until this point. All of our metric prefix conversions, right? So going from kilo to milli, that sort of thing. That's what last lecture was all about, right? So that information is on here. But there's also stuff on how to convert from different distance measurements, right? So, or different distance measurements, going from meters to inches or inches to centimeters, okay? We have something similar with volume. We can go from liters to gallons or from, I don't even know, pints to cups, something like that, right? So that is what these tables are. We have for mass as well, going from grams to pounds or kilograms to pounds, etc. Okay, so all that information, this is basically a giant list of all these conversion factors. And I want to point out that the ones that are starred are the exact conversions. And remember what it means to be an exact number. It means that it's not going to change the number of sig figs from your original measurement. So when we use one of these exact conversions to go from, say, if we look here, going from inches to centimeters, this is an exact measurement. If I started out with a number that had 5 sig figs, my answer will have 5 sig figs because I'm going to multiply by this exact conversion factor. Okay, so this is a good one to start out with. How do we get a conversion factor from the information on this table? Well, what this box right here is telling us is 1 inch is equal to 2.54 centimeters, right? And remember how we did this last time with our metric prefix conversions. We can create this, or from this statement, 1 inch equals 2.54 centimeters, we can create the conversion factor 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. So these would be the conversion factors that we get from this line on our constants page. And this is what we would be using mathematically to convert from inches to centimeters or centimeters to inches. Okay, so if I had 12 inches and I wanted to convert to centimeters, I would use this conversion factor, the one that we just found from our table, right? But I would, if I'm going from inches to centimeters, then I'm going to use which one? I want to make sure to use the one where inches is on the bottom so that inches will cancel out and I'll be left with centimeters. Okay, and again, first step, you're just going to punch it into your calculator. 12.00 times 2.54, that spits out this 30.48. Then I'm going to go and do units. Inches cancel out with inches, and I'm left with centimeters. And then what's the last step? Sig figs. This number over here has 4 sig figs. And again, this 2.54 is exact. So even though you're tempted to look at it and say that there are 3 sig figs, it's an exact conversion factor, which means that it's not going to limit the number of sig figs in my answer. My answer should also have 4. Okay. So this is how we're going to do these conversions. It's going to be all about mining this information from this constants page here to convert from anything, that could be on this table. All right, so we'll do some practice here. Let me get rid of this because I know it's going to be a burden in the future. Cool. All right, so we can get conversion factors from that table. The other thing that we can use as a kind of a conversion factor is actually this measured value of density. So each substance can be characterized by its density. The density of a substance is the mass that it has over the volume that it occupies. Okay, so this would be a quantity that would be measured in something like grams, which would be mass, per milliliter. That would be a density. You might have always heard that like adage that a pound of gold is the same mass as a pound of feathers, right? That's very true. The big difference is the density of those two, right? A pound of feathers is much larger than a pound of gold, which is very small, right? So the mass would be the same, but the volume occupied is much larger for the feathers than the gold. So those would be different densities that they have, right? So density is kind of a measure of compactness. If you have a really high density, that means given a small amount, it's very heavy, compared to a low density will be a very small amount, is not very heavy, right? So air has a very low density, whereas metals have a very high density. Okay, but we can use density almost as a conversion factor for a particular substance to convert between mass and volume. All right, it's unique to a particular substance, right? So water has a different density than aluminum, has a different density than air. You would have to be given the density of whatever material it is that you're talking about. But if you were given a density, you could convert from grams to milliliters, just like we do with our other conversion factors. So let's do an example here. So first of all, we're going to calculate the density of an ice cube that is 2 centimeters on either side. So let me draw my ice cube here. And has a mass of 7.36 grams, right? So density equals mass over volume. I'm given the mass is 7.36 grams. For the volume, I'm gonna have to do some geometry here actually, where I have a cube, so this side's 2 centimeters, this side's 2 centimeters, and the height is 2 centimeters. So the volume would be length times width times height, or this 2 centimeters cubed, which would give me 8 centimeters cubed. Notice how I'm having to combine those units because it's multiplication. So this is 8.0 centimeters cubed, would give me a density of 0.92 grams per centimeter cubed. Okay, and I'm going to make sure I have correct sig figs. This number has 3 and this number has 2. So it kind of works out that what my calculator spit out already had the correct number of sig figs. Okay, so that's all well and good. I think more importantly, though, I can't. More importantly, though, is part B of this problem, which now I'm going to use this density, this conversion factor here, to determine the volume occupied by 23 grams of ice at 0 degrees Celsius. So again, actually, okay, I gotta move this over. It's going to bother me. Okay, so now going for part B here. I have 23 grams of ice, and I know that its density is 0.92 grams per centimeter cubed. What I'm going to do with this density information here is I'm going to convert it to put it in the same form that I'm used to seeing for my conversion factors, which would be 0.92 grams per 1 centimeter cubed. Right? That's a conversion factor that I know how to use. And I can, same with my other conversion factors, I can also flip it. So 1 centimeter cubed over 0.92 grams. Either of those can be used. So if I want to know the volume occupied by 23 grams of ice, which conversion factor am I going to use? I'm going to use the one that allows me to cancel out grams and put it in centimeters cubed, which is a volume measurement. So here I'm going to multiply by 0.92 grams, 1 centimeter cubed, punch that into my calculator, and I would get 25. Grams cancel, and I'm left with centimeters cubed. And the last step would be to check sig figs. In this case, this number has 2, and this number has 2, so my answer should have 2, which it does. So boom. But notice how I just used density to convert from mass to volume for a particular substance. Okay. We can do a type of conversion called dimensional analysis. I think it's a really wordy name for what you're doing. Basically, this is now going to be stacking multiple conversion factors, okay? So now let's say that I wanted to go from inches to meters. Well, I don't know how to do that all in one shot, okay? Actually, I think that there is a constants page, a thing on your constants page, yeah. So I actually could do it all in one shot because the constants pages that we have gives us this. Okay, but let's say that I didn't have that. I could still do it based on the information that we were given by stacking 2 different conversion factors. And that is going from inches to centimeters. I know how to do that. And I also know how to go from centimeters to meters. So I can do those 2 conversions back to back. This is what would be called dimensional analysis. Again, I don't like that term. I think you're just sort of stacking conversion factors. But so I'm going to take my conversion factor that we figured out in the first place, right? Going from inches to centimeters. And then I'm going to stack my next conversion factor that takes me from centimeters to meters, right? We know how to do that as well. This is one that we found from that metric prefix table. And so then what would happen is you just punch it all into your calculator. A lot of students like to do these in multiple steps. They'll do 12 times 2.54, then hit enter or copy it down on the paper and then do the next one. You want to get in the habit of running these all into one line on your calculator because it will save you from making a copying error. Okay, so you could do 12.00 times 2.54 divided by 1 times 10 squared, all in one shot, and that would give you the following answer. Okay. The last step, or the second step, would be units. And again, the way that we set it up was so inches would cancel, centimeters would cancel, and I'd be left with my meters, which is what I wanted. And then the last step is to do sig figs. The only trick being that you got to remember what quantities are exact and what aren't. Again, it's on the constants page. It's when you have 2 little dots here. Notice that all our metric prefixes are exact conversions. So this has 4 sig figs. This is exact. This is exact. So I have 4 in my final answer. Okay, but that's how we can sort of go, multiple jumps in our unit conversion. All right, so let's do 2 more conversions here. The first is going from 5.2 liters of blood to the volume of blood in gallons, right? So how would this problem look? I have 5.2 liters and I want to go to gallons. Okay, so what am I going to have to do? Where am I going to look? I'm going to go to my constants page. I'm going to go to the volume section. And I see that I have a liter to gallon conversion right here. I also have a gallon to liter conversion here. It doesn't matter which one of these you were to use, right? If you were to say 1 gallon equals 3.785 liters, or 1 liter equals 0.26417 gallons, and convert either of these statements into a conversion factor, you would get the exact same answer. Okay, so you could just pick one and go with it. It'll always give you the same answer. Let's go ahead and use this one here. All right. Oh, and importantly, so if I'm going to use this one here, what am I going to do? I'm going to convert it into a conversion factor. So that's 1 gallon over 3.785 liters, or 3.785 liters over 1 gallon. My problem wants to go from liters to gallons. So which one of these would I use? I'm going to want to use this one so that liters cancel. So 5.2 liters times, what was it, 3.785? Okay. Step 1, punch it into your calculator. We get 1.3736 gallon. Oh, step 1, punch it into your calculator. Step 2, units. Liter cancels with liter, and I'm left with gallons. Good, that means that I set it up correctly. The reason that you want to do this in as a second step is basically just to make sure that you've actually set up your problem correctly. As long as you've set it up correctly, the units will all cancel out beautifully. That's a great way to check that you haven't actually flipped a conversion factor or something like that. And then what's the last step going to be? Sig figs. This is not an exact conversion. Notice how there is not a star in this conversion factor here. So this could limit the number of sig figs. So I got to pay attention. This has 2 and this has 4. So the 2 is fewer. So that means I'm going to round to this place here. So the final answer would be 1.4 gallons. That's how much blood you got. Okay. So find your conversion factor, set it up so that your units cancel, punch it into your calculator, make sure your units all cancel, and then you worry about sig figs. That is unfortunately the very big pain in the butt way that we do math as chemists. It's got a few more steps than it would in just a simple math class. Okay. FDA recommends sodium be no more than 2,400 milligrams per day. How many pounds of sodium would that be? Okay, so I'm going to, the problem is asking me to go from 2,400 milligrams to pounds. I'm going to go to my constants page. Let me get rid of this. I'm going to go to the mass section. I have grams to pounds or pounds to grams, but I don't have pounds to milligrams or milligrams to pounds. So that means I'm going to have to do this in more than one step, right? We're starting off with milligrams, and then finally we want to get to pounds. So I'm going to have to go from milligrams to grams, and then I can use one of these conversion factors and go from grams to pounds. Okay, and again, I have 2 of them given here. It wouldn't matter which one I picked. I like this second one better, just for no particular reason. All right, but again, the first thing I'm going to have to do is go from milligrams to grams. Once I get it in grams, I can go from grams to pounds. So in order to get to milligrams, I'm going to have to use this factor right here. And remember, what is my table saying? my table is saying that 1 milligram is equal to 10 to the negative 3 grams, right? So my conversion factor would be 1 milligram over 10 to the negative 3 grams, or 10 to the negative 3 grams over 1 milligram. Right? I'm gonna have to use one of those two. Since my problem has me starting in milligrams, I'm gonna use the conversion factor that has milligrams on the bottom. So 2,400 milligrams times 1 milligram is equal to 10 to the negative 3 grams. So if I stopped right here and did my calculation, my answer would be in grams, right? But I want to go one more step. I want to go from grams to pounds. So then I'm going to use that information I highlighted in blue. Okay, so I guess I can actually color code things. This would have been how I got these two conversion factors, and I decided to use this one. If I'm going to use what's highlighted in blue here, this is telling me that 1 pound equals 453.59 grams. So I'm going to put that into our conversion factor form, or 1 elb over 453.59 grams, or 453.59 grams over 1 pound. All right, these are the two conversion factors that I got from that line on my constants page. And then going back to my problem here, which one am I going to want to use? I need grams to cancel, so I'm going to use the one on the right. All right, punch this into my calculator. Okay, this is what my calculator spits out. Then I'm going to go make sure that I've set everything up correctly by doing my units. Milligrams will cancel, grams will cancel, and I'll be left with pounds. And then what's the last step? Sig figs. This 2400 has 2 sig figs. My metric prefixes are always exact. And then this conversion from pounds to grams, if we look on our table, it is not starred. So it is not an exact conversion, but I do have 5 sig figs associated with that. So 2 is my limiting. So I would round to this second digit here, second significant digit here. So my final answer would be 0.053 pounds.